Hello everyone, welcome to Basics e-learning.
I'm going to start my lectures on signals and systems. Signals and systems is a core subject for undergraduate students in electronics and communication engineering, electrical engineering, and electronics and instrumentation engineering. So in this video, I'm going to explain what is a signal and different types of signals. Let us understand what is the meaning of signal. A signal can be defined as a function that conveys information. These signals are generally represented mathematically as a function of one or more independent variables. Generally, signal is a sequence of values to represent some information. Examples are temperature, current, voltage, electrical intensity, force, etc. As I said, mathematically, signal is a set of independent variables. If the signal depends upon only one variable, then we call it as a one-dimensional signal, whereas if it depends upon two or more independent variables, then we call this signal as multidimensional signal. So examples of one-dimensional signal are voltage. So let us consider a voltage signal here. So this is your voltage and it depends upon time. That is, the voltage varies with respect to time. The voltage depends only on time. So this is called one-dimensional signal. Coming to multi-dimensional signal, example is force. Force is a function of mass and velocity, right? As you know, force is equal to ma. It depends upon mass and also velocity. As it is depending upon these two independent variables, so force is defined as a multidimensional signal. Signals are classified into 6 types. The first one is continuous and discrete signals, then analog and digital signals, discrete and random signals, even and odd signals, periodic and aperiodic signals, power and energy signals. Now I am going to explain all these types with a detailed explanation. The first type is continuous and discrete signals. A signal x of t is said to be continuous if t is a continuous variable and if x of t is defined at only discrete instants of time, then x of t is called discrete time signal. Generally, discrete time signal is represented with x of n. So if you see the first picture here, so here x of t is the signal that is continuously varying with respect to time, where time t is the independent variable. So that is, x of t has an amplitude. At any instant of time, you have an amplitude of x of t. So the amplitude varies continuously with respect to time. Then we call it as a continuous signal. Example here is heartbeat. Then coming to the second picture, this is the discrete time signal. It is defined only at discrete instants of time. So usually the time gap between the instants is uniform here. That is, here see 0 to 1, 1 to 2, 2 to 3. The gap between the instants is generally uniform. So discrete time signals represented mathematically as a sequence of numbers equally spaced. We can get this discrete signal by sampling the continuous time signal. Coming to the second type, this is analog and digital signal. If a continuous signal x of t has a range minus infinity to infinity, then we call it as an analog signal. Similarly, a discrete signal x of n has only finite number of distinct values, then we call it as a digital signal. So if you see the picture here, this is analog signal that is continuing. So there is no starting or ending point, then such type of signals we call it as an analog signal. But this is also a variety of continuous time signal. That is, at every instant of time you have some value. Coming to the digital signal, here if you see, it has only two distinct values. That is either the high level or 0 level. So it has two distinct finite levels. such type of signal we call it as a digital signal. Now if you have only two levels, that we call it as binary signal. Now coming to deterministic and random signal. Signals are defined as deterministic if their behavior is expected, and if the behavior is impossible to specify, then such type of signals are known as random signals. This is the first signal. Suppose say if you are drawing 4 sine waves and you're left with, then the remaining part of the signal can be estimated and can be drawn. Such type of signals we call it as deterministic signals. That is, the behavior of the other part of the signal can be expected from the previous part, right? So such type of signals are deterministic signals. Examples: sine wave, square wave, anything, right? So coming to the random signal, if you see, the signal amplitude is varying unevenly, right? So the behavior cannot be expected. If you are drawing half part of the signal and the next part we cannot specify, right? So such type of signals we call it as a random signal. Example: noise generated in the radio receiver, ECG signals, etc. The next variety here is even and odd signals. A signal x of t or x of n is said to be even signal if x of minus t is equal to x of t or x of minus n is equal to x of n. Similarly, a signal is said to be odd if x of minus t is equal to minus x of t and x of minus n is equal to minus x of n. So here x of t is for continuous time signal and x of n is defined for discrete time signal. So I'll explain you the condition here. So if you're drawing a signal with respect to t, this is my signal x of t. I am drawing with respect to the time scale t here. So this first quadrant, if you're drawing the part of the signal in the first quadrant, see here, you're drawing the signal x with respect to t. So this first quadrant gives me x of t. If it is t, then this will be negative of x-axis, no? So minus t. If this is x of t, this part is my minus x of t, right? So this is y-axis, no? This is minus y. So minus x of t. If you're drawing the signal in the first quadrant, that is x and t. So x of t I'm writing here, right? So if you're drawing the signal in the second quadrant, that is with respect to minus t axis, this second quadrant part indicates the signal x of minus t. Similarly, in the third quadrant, this is minus x of minus t. In the fourth quadrant, I can write it as minus x of t. That is, this is for minus x of t and t. Here it is drawn with respect to minus x of t and minus t, right? So now, if you check the condition here for the even signal, x of minus t should be equal to x of t. That is, this is x of minus t and this is x of t. That is, if you draw a signal here in the first quadrant and second quadrant, if both the signals are similar, then we call such signal as an even signal. See here, in the first picture here, see, this is the first quadrant. The signal drawn here is in this shape. Similar way, you're drawing the same similar type of waveform in the second quadrant also. Then such type of signal we call it as a even signal. So if you observe, this is nothing but there is a symmetry around y-axis here. So that is, if you fold the paper along your y-axis, the signal has to fall on each other, right? So then such type of signals we call it as a even signal. Coming to the second condition here, odd signal here, x of minus t is equal to minus x of t, right? Where is x of minus t? In the second quadrant. Minus x of t means fourth quadrant. If the signal in the second quadrant and the fourth quadrant is equal, then we call it as an odd signal. Or else, suppose say, if you multiply this x of minus t on x of minus t is equal to minus x of t. Now suppose if you multiply with minus on both the sides, see here, this is nothing but x of t is equal to minus x of minus t. That is, the first quadrant is x of t, minus x of minus t means third quadrant. So the signal in the first quadrant should be equal to exactly the same shape as your third quadrant, or else second to fourth. That is, we call it as anti-symmetric around y-axis. See here, if you see here, this is the signal that is drawn in the first quadrant, right? So similarly, you're drawing the similar shape here in the third quadrant. That is, it is anti-symmetric around y-axis. That is, if you fold the signal, if you fold the paper here, this part will look like here as it is shown in the even signal, right? Now again you fold it down on the y-axis, x-axis, then it looks like this, right? So such type of signals we call it as anti-symmetric around y-axis. So if the signal matches, that is the shape of the signal is symmetric in first quadrant with respect to the third quadrant, then such type of signals are called odd signals. And if it is symmetric around y-axis, that is with respect to first and second quadrants, then we call it as a even signal. So as I said, the signal, any signal x of t can be divided into even part and odd part. So let us take the signal x of t that I am writing as a summation of even part and odd part, xe of t and x naught of t. Suppose if I replace t by minus t, what happens? Wherever t is there, I am writing minus t. So xe of t plus x naught of minus t. Xe of t is the even part and x naught of t is the odd part. You know the condition for even signal, right? So xe of minus t should be equal to x of t. X of t is equal to x of minus t, no? That is even signal. Similarly, for odd signal, x naught of minus t should be equal to minus x naught of t, right? So now I'll try to substitute here. Xe of minus t is nothing but I can write it as xe of t, and x naught of minus t can be written as minus x naught of t. So this is nothing but my x of minus t. Let us call this as equation 1 and equation 2. Now add both the equations 1 and 2. On my left hand side, I'll get x of t plus x of minus t. Right hand side, this x naught of t will get cancelled. I'll get 2xe of t. So that is nothing but xe of t is equal to x of t plus x of minus t divided by 2. That is, if you want to get the even part of the signal, take the signal, then take the x of minus t, that is the vertical symmetry, right? So then you add both the signals, make it half. That gives you the even part of the signal. Similarly, you subtract both the signals here. So the left hand side I'll get x of t minus x of minus t, and the right hand side I'll get 2x naught of t. So I'll get here x naught of t is nothing but x of t minus x of minus t divided by 2. That is, take the signal and then take the vertical symmetry of the signal, then subtract both the signals, divided by 2. The amplitude you have to make it half. That gives you the odd part of the signal. Similar way you can write for the discrete time signal also. Instead of t, you can replace with n. So this is how you can find out even and odd part of the signal when a signal is given. Periodic and aperiodic signals. A signal is said to be periodic if it repeats in particular intervals of time. Otherwise, it is aperiodic. X of t plus capital T is equal to x of t is the condition for continuous time signal. Similarly, x of n plus mn should be equal to again x of n for a discrete time signal. Here, this capital T is called fundamental time period. This is the smallest integer. So, after every t intervals of time, again the signal has to repeat. Then such type of signals we call it as a periodic signals. See here, this is the signal that is repeated again and again here. So, if you observe the signal here, the amplitude and this is the time, this is the periodic analog signal example. See, after this cycle, again the same signal is repeated again and again. So, after a particular interval of time, let us say this is the fundamental time t we call. So, after this again at every particular interval of time the signal is repeated. Such type of signals we call it as a periodic signal. Similarly, if you see a digital signal 1 and 0, this is the signal, fundamental signal. that is repeated again and again here. So again, this digital signal is also called as periodic. Now coming to the example 2 here, the signal is randomly varying. So this part of the signal, nowhere it is repeated after a particular interval of time. Then such type of signals we call it as a aperiodic signals. So this is the example of a periodic analog signal, and this is showing a periodic digital signal. So if you observe in the digital signal 1, 0, 0, 1, 1, 0, 1, 1, 0 here, 0 here, 1, and then 0, 0, 1, 1. The signal is going on, but it is not repeating at any particular interval of time. So then such type of signals we call it as a aperiodic digital signals. This is the last type, energy and power signals. The signal x of t is said to be an energy signal if and only if it has a finite amount of energy. That is, the energy value, the total energy value should be less than infinity. Similarly, the average power contained by the signal should be equal to 0. Then such type of signals we call it as energy signal. If it satisfies both these conditions, then we can say the given signal is an energy signal. The signal is said to be power signal if and only if the average power content of the signal is a finite quantity. That is, the power, average power should be finite. And one more condition here is the total energy contained by the signal should be equal to infinity. So all the power signals will have the energy as infinity here. So to check whether the given conditions for the energy and power are satisfied or not, so these are the formula here. For energy signal, take the signal x of t, square it and apply it from minus infinity to infinity. Because this is an analog signal, as the signal extends from minus infinity to plus infinity, check whether the signal, the total energy contained in the signal is less than infinity or not. If using this formula, if you check whether the energy quantity is a finite number, then we can say the signal is energy signal. Similarly, for a discrete time signal, as the signal is analog signal, it extends from minus infinity to infinity. I am finding out the average here, right? Similarly, power signal. So you know, power is nothing but rate of change of energy by time. So the same way, I am writing the energy formula and then up by t I am writing, right? So as we are telling, this is the average signal. So I am calculating only for a particular interval of time, minus t by 2, t by 2. Similarly, here also minus n to n. So if the condition satisfies here, then we say it's an energy signal. If these conditions are satisfied, then we can say that is a power signal. Again, energy signal and power signals are mutually exclusive. That is, a signal can either be energy signal or be a power signal, but cannot be both.
For more videos, please do like, share, subscribe to our channel. Let us know your suggestions and queries in the comment box. Thank you.